So, what are we doing? We are doing rationals, but specifically we're going to take a look at some limits. Alright, so have we talked about limits yet? No. We have not. Okay, so this is going to be fun. So a limit is basically you're asking what happens to the function as x approaches a certain value without ever getting to that value. So definite limits are actually pretty easy to do. So if I had a function f of x equals, and we'll just do a simple one, x squared minus 5x, and I wanted to do the limit as x approaches 4 of f of x. Well, I'm asking what's happening to the graph as it gets really, really close to 4. So let's go ahead and graph that. So we'll complete the square really quick. So we do a half of b, which is half of 5, which is 5 halves, square it, 25 fourths. And then we factor that, so that's x minus 5 halves squared. Now if we added 25 fourths to the right, we'd have to add it to left, so that means we need to subtract it over here. 25 fourths is approximately what? 5, 6, it's about 6. This is 2.5. So our vertex is 2.5, negative 6. 1, 2, 3, 4, 5, 6. And no stretch or anything. So it looks like something like this. You don't have to graph this. Okay, I'm just trying to show you. Now what we're interested in is what happens to my graph, what happens to the function as x approaches, according to this, as it approaches 4. So I look across my x-axis and I'm like, okay, I'm going to go to 4. And I'm going to know where my graph is. What's happening to my graph as I get to 4? So I'll just kind of trace it in my mind. And it's getting close to what appears to be this value right here, negative 4. Okay? So for a definite limit, for a definite limit, this is pretty simple. I'm going to take that 4 and put it into this. 4 squared minus 5 times 4, get 16 minus 20, and get negative 4. So that limit is simply negative 4. That's easy. You basically evaluate. Now, it's very important to remember, for a limit, we're asking what happens to the function as it gets really, really close, as it approaches to a certain value, but never gets there. Okay, it gets really, really close to it. So I get really, really close to 4, but I never actually get to 4. So that means this is the limit. I don't cross the threshold of negative 4. So for other definite limits, like if I give you another function, g of x equals, say, 5 over x plus 2. So this is a rational. It has an asymptote at what? A vertical asymptote where? At negative 2. So if I took the limit of this, limit of g of x as x approaches, say, 8. again, I would put in 8 here. And I get a half. So it approaches a half. This is a definite limit. But what if I do that limit of g of x as x approaches -2? If I put in -2 here, do you see what happens? I get 0 at the bottom, right? And this is undefined because I have an asymptote there. Alright, so let's try to graph this. Get your calculator handy. No, you don't need my calculator. Just a calculator will be fine. Alright, so let's do a quick table of values. So in your table, or you can just type this, we'll do a few. We'll do -4, -3, -2, -1, 0, 1, 2, 3. Alright, y, and we're doing 5 over x plus 2. That's our function. So if I put in -4, what do I get? Huh?
Negative of it.
Okay. If I put in -3, what do I get?
Negative of.
Wait. Yep. Okay. And if I put in -2, it's no, can't do that. If I put in -1, if I put in 0,
0. No, no, 5.
5 halves. If I put in 1, 5 thirds. If I put in 2, 5 fourths. If I put in 3, 1. So 3 is 1. So you can always graph with the table of values. This is just above 1, right? And this is a little bit further. 0, 2.5 basically. And -1 is 5. Okay, -2 is our asymptote. Okay, and then if I graph this, -3 is -5. So you can always graph with the table of values. Just remember that. Alright, and then these are going to reflect, so I'm not going to graph those points. Alright, so if I connect those points, this appears to be what happens. Okay, so we're trying to figure out, well, what's the limit of this function? This is g of x as x approaches -2. And the answer to that is going to really depend. If I'm coming from this side, like I'm going this way, what's happening to my graph? Well, it appears to be going really, really negative. Do you see that? It's going down. And it's going infinitely down. So if I do, so this is a handed limit. If I do limit as g of x as x approaches -2, if I do that from the negative side, I get -infinity because it goes infinitely down. But if I do the limit of g of x as x approaches -2 from the positive side, so if I go this way on my x-axis, notice what's happening to my graph. It goes infinitely big. So then the answer is positive infinity. So negative side was negative, positive side was positive infinity. So I don't know why I have this up here. I guess it opened up an old save. So we have a right-handed limit. That would be the positive side, and we have a left-handed limit. And that would be from the negative side. And that just is how I'm going to look at the graph overall. So if I do a quick sketch right here of some other function, just make it as complicated as I possibly can. Okay, now get us some points here. This point is obviously 0, 2. This point here is meant to be negative 2, 1. This point here is meant to be negative 2, negative 2. This point is meant to be 2, 2. This point is 4, 0. And this point is, we'll say, 4.5, 1. Alright, and this point right here, what's that? That is like, I don't know, we'll say that's a half 3, right there. Okay, so let's do a few limits. Let's say I want to take the limit, and we'll call this is the graph of some function f of x. Let's say I want to take the limit of f of x as x approaches negative 2 from the positive side. You see how I wrote that? I'm going to go towards negative 2 from the positive side. So just watch as I do this. So here's what I'm doing with my eye or with my pencil. I'm starting at the positive side of my graph, and I'm going to move over to negative 2 and see what's happening to my graph. So here's negative 2, and look what's happening to my graph as I go this way, as I go to the left. I start at the right and go to the left, because that's a right-handed limit, so I start at the right. My graph, as I get close to negative 2, seems to be approaching what value? Do not say negative 2, because that's next value. I'm asking about f of x, the y value. What's happening to the y value as I get close to negative 2? It's approaching what value? No, it is not. It's approaching 1. Okay, as I get really close to negative 2, here's negative 2, the value approaches 1. So the answer is 1. But what if I take the limit as x approaches negative 2 from the negative side of f of x? So now I'm going to start at the left and see what happens to my graph. So as I start at the left and I go this way, see what I'm doing? What's happening to my graph as I approach negative 2 from the left-hand side? It's approaching what value? Negative 2. And when I say that, I'm talking about the y value. Alright, so that our answer there is going to be this time negative 2, because it matters which side I come from, because this graph is all split up and choppy. Alright, let's try it a different one. Let's try the limit of f of x as x approaches 1 from the negative side. Alright, so I'm going to start at the left. I'm going to look with my eye. And what is happening to the graph as I approach 1 from the left? It goes towards what value?
3.
Nope. Here's 1. Look at this arrow. It gets really... It never actually reaches a value. It gets infinitely big. Okay, see, this is a half. I'm approaching 1 from the negative side. 1 is right here. I have an asymptote. Okay, so that's approaching infinity, because it's getting infinitely big. Do you see that? Alright, limit of f of x as x approaches 1 from the positive side now. If I come from the positive side, what's happening to the graph as I get really close to 1? What's happening to the graph as I get really close to 1? Negative infinity. It gets infinitely small. Alright, let's do the limit of f of x as x approaches, let's approach 2 from the positive side. 2 is right here. Tell me what's happening to the y values as I get close to 2. What are they getting close to? should be negative. It's not a trick question. As I get close to the f of x being x being 2, what happens to my graph?
-2.
It's getting close to, just look, it's getting close to this point, -2. So it approaches -2, not a trick question. If I do limit as x approaches 2 from the negative side of f of x. So I start over here, and I look, my graph starts going up, and it approaches what value? As I get close to 2. -2 again. It's the same. So if it's the same, we're really happy. It means that my function is defined there, and it's continuous. Alright, let's try another graph. Do not make this harder than it needs to be. It's really just tracing the graph, guys. That's all you're doing. Tracing the graph. It just matters which end you're coming from. Here, get a sketch of this. This is -5, 2 right there. This is 5, -1, -5, 1. Oh, that should be a 3 right there. -5, 3. 4, 5, 3. +5 right there. -2, 2. Zero, 1, 2, 3, 4, 5, 0, 5. So here is 2, 4. And let's see, this was 2, 2. 1, 2, 4, 5, 5, 0. 6, 1. Okay. Give me a moment to get that down. And we'll say this is some function f of x.
Is that a point and another point?
Left corner? Oh, right here, yeah. So -6, -3. Really, these are just reading values off of the graph. You just need to determine which side you're coming from, which end you're tracing from. I'm not going to do all the possibilities here of things that we could calculate. We'll do a few of them. Okay. So, limit as f of x approaches -5 from the negative side. -5 from the negative side. So I start at the negative side and I go till I get close to x being -5. What value do I approach?
-1.
-1. Do you see how I did that? I just traced starting at the left and I got stopped when I got close to -1 and I asked, or -5, and I asked, okay, what's the y value? What am I getting close to? Now suppose I go from the positive end. Now I don't need to start way over here. You know, I could start closer to the value. So I'll start right here, see where my pen is. I'm tracing and I'm getting close to -5, but I'm going from the positive side. Okay, I'm getting close to -5. The value is approaching what?
3.
3. It's easy. No, nothing tricky about this. And see, if you know left and right, you can do this. Okay, maybe that was a bad sign. Some of us don't know left and right. If it's from the negative, you start on the left. If it's from positive, you start on the right. And you just ask, what is the graph getting close to? So this is -3. I don't tell you which side, so it shouldn't matter. So as x approaches -3 from either side, what's it approach?
5.
5. Okay. This one, limit of f of x as x approaches 2 from the negative side. So 2 is over here. See 2. And I'm going to start at the negative side. So start at the negative side. This is the negative side. And I approach 2. And I get close to
4.
4. Okay, what if I start at the positive side and I approach 2? So this is the positive side. I get close to 2. Do you see how we do this? It's not that bad. This is like Mr. Kane gives you a picture and you like trace the picture. This is connect the dots, 12th grade level. Mrs. Edwards gets it. All right, so we're going to go to -4 or to 4 from the negative side. So that would be the left. So that means I started left. I don't need to start all over here. Here's 4. See, I have an asymptote. So I'll start over here. I start at the left and I approach
Infinity.
-infinity specifically. Okay? What about 4 from the positive side? So if I start at the positive side and I get close to 4, what do I approach? -infinity again. Alright, and the limit as I approach 6. So I don't tell you from which side. So it has to be like not matter, no jumps or hops. So if I get to go close to 6, it approaches 1. Alright, on your own, figure out what the limit is as x approaches -1 from the negative side, and the limit as x approaches -1 from the positive side. See if you can figure out each of those. Okay, we are going to go ahead and say that this one, as I go to -1 from the negative side, is -infinity, and the limit as x approaches -1 from the positive side is +infinity, because it goes really high. Does that make sense?
Mm-hmm.
All right, good. All right, so we're going to put aside limits for now, and we are going to talk about finding vertical, horizontal asymptotes and intercepts for rationals. Now, vertical asymptotes, just to rehash what we've already talked about multiple times for rationals, this is when the denominator equals 0. In horizontal, we had this where we compare our highest power. So we find our highest power of x, and if the numerator is greater than the denominator, then we're going to have a slant. If numerator equals the denominator, then it is the coefficients on those. And if the numerator's power is less than the denominator, our asymptote is y equals 0. Intercepts. A y-intercept happens when x equals 0. So that's pretty easy to figure out. So we're going to answer all those questions for a fairly difficult problem. So here's our f of x. Now we've done these with up to powers of 2 because we knew how to factor those. But now we've gone through synthetic division and all that, we can actually factor higher powers of x. So I'm going to go ahead and grab this function so that we can have lots more space. Alright, let's go ahead and factor this. So the denominator is simple, right? That factors to x minus 1, x plus 1. Now for these, I don't need to factor them such that I get any complexes. Those are not going to matter. I need the real factors. Alright, so luckily my only possible factors for this are plus or minus 1 and plus or minus a half. So not much to choose from here. So I have 1. Let's try 1. Now I need to fill in a bunch of things here. So I have a cube and a fourth power that are zeros. And we're going to factor this puppy. Alright, let's try 1. So 2. Oh, this should have been a 2. My bad. My bad. I'm a bonobo. 2 times 1 is 2. It didn't work? Alright. Everyone's saying no. That one doesn't work. Alright, let's... Oh, shoot. I shouldn't have put it in that way. Alright, so 2, 0, 0, 1, negative 1, 1. Let's try negative 1. So 2, negative 2, negative 2, 2, 2, negative 2, so negative 1, 1, uh-oh, 0, 0, 1, so 1 doesn't work?
What?
Did you guys get it to work, or did I do it wrong?
No, I got it theoretically.
You got this?
No, yeah, I got it.
Yeah, okay, so that didn't work.
If a half.
A half. Looking like a half.
Did you do another problem with that?
Yeah,
Does it
wouldn't
work?
that be convenient? Alright, so this is 1. So 1, so a half, a fourth. So that's going to be 5/4. That's going to be 5/8. Negative 3/8. Yeah, that doesn't work. Really, Kane? Choose the one question that is horrible? We must have done something wrong.
Did you write the problem down?
Yeah, probably. Negative a half.
I'll let you do it far out.
Yeah.
So 2, negative 1, negative 1, positive a half, positive a half. Stop that. Negative a fourth, 3/4, negative 3/8. We have a chance, though. We actually have a chance. When I add those, I get 11/8. When I multiply that, I get positive 11/16. Okay, so no, we don't have to. Really quick, on your calculator, graph that and see if it crosses anywhere. Maybe it just doesn't, and I guess that's possible. Do we have any roots? We probably should have started there and not wasted all that time.
We got one at negative 1.1 and
What? Negative
This one.
1.1.
yeah,
Oh, it's an irrational root. That's why. Okay, so we aren't gonna be able to find that. All right, so we're gonna find the verticals, and we should have a vertical asymptote at.
It's just line.
I'm not to horizontal yet.
1 and negative 1.
Yeah. So x equals 1, x equals negative 1. Okay. Now judging by your graphs though, let me see your graph.
Mine's probably wrong.
What's my view window supposed to be on?
You said the default.
Huh.
I don't know how to do that.
It's looking like 1 and negative 1 should have worked on when we divided that. I'm going to try it one more time. 2, 0, because 4, third power, first power. No, that's second power, first power. Let's try 1 again. Because it's looking like there should be a hole there. 2, right? 2. 2.
2.
2.
2.
2. 3. 3.
Negative
Positive 2.
2. Positive
2. Okay, so not at 1. I don't know.
This one right.
I don't know. It looks like from your graph there's a hole there, but whatever. Alright, so horizontal. Alright, so we see in horizontal that we have this case where there's a slant. So there's no horizontal one, there's supposed to be a slant. So I actually have to divide this, but I have to do it by long division. So, oops. Okay, so this is going to be where you actually have to use that long division. I have x squared plus 0x minus 1. And we have 2x to the 5th plus 0x to the 4th plus 0x cubed plus x squared minus x plus 1. I actually have to divide this. So I get x cubed, 2x cubed, that I have to multiply this by to get this. And that's going to be minus 2x cubed. See, you divide, then you subtract. The x to the 4ths don't matter, and I'm going to get a positive x cubed. I don't know what I'm going to bring down, so I won't bring down just yet. Well, nah, I'll bring down everything. To get this, I need to multiply by 2x, so plus 2x. So I get 2x squared. The 0 doesn't matter, so minus 2x.
Like 2x squared.
It should be cubed. 2x times x squared is 2x cubed. 2x times 0x is 0. And 2x times negative 1 is negative 2x. Now I subtract. Those cancel. That's going to be a positive. So I get x. And I bring down my x squared. And then it's times 1. So plus 1. So I get x squared minus 1. And we're going to get x plus 2. So remainder x plus 2. So our slant is y equals 2x cubed plus 2x plus 1 plus x plus 2 all over x squared minus 1. Our divisor. That's our slant. Alright, so we calculated our slant. We don't have horizontal or anything like that. And then our y-intercept. So I'll just do the y-intercept really quick because that is so easy. I replace x with what?
0.
So that goes away, it goes away, it goes away, it goes away. And the y-intercept is y equals 1 over negative 1. So negative 1.
Wow.
Y-intercept's easy. You replace x with 0. That was not the most beautiful problem to start with. So let's try another one. Okay, so we are going to have to use synthetic division on both of these. So let's go ahead and get our possibles for the top one. So I'll let you graph the top one, and the bottom one we have x cubed. Oops. So we have a few missing things. So I'm going to do the bottom. So we have 1, 0, 0, 1. I'm going to try negative 1. That one worked. And then that's not going to factor any further, I'm pretty sure. So we get x plus 1, x squared minus x plus 1. I mean, you could try to do this, but we want only the real one. So if you got complexes or irrationals or anything really weird, you're not going to worry about that. We want the real roots. Right here, did we have any intercepts?
Just 1.
What is it?
1.
1? Alright, so let's go ahead and get that one. So we get 3, 0, 1, negative 4, and Canbo says 1 works. So we get our numerator. And that one does work. So that's x equals 1. So x minus 1 is our factor, right? And we get 3x squared plus 3x plus 4. That must not factor very nicely at all. Okay, so nothing cancels, so we have a vertical where?
X equals 1.
X equals negative 1.
Negative 1.
And I will have to do quadratic on this to get the other two. So x equals negative or positive 1 plus or minus square root b squared. So that's 1 minus 4 times a times c. And notice right in here, this is why I did this. This inside's negative, so it's imaginary, so it doesn't matter. So we don't need that. Horizontal. Which case do we have? Is numerator bigger than in power than denominator, equal to, or less than? It's equal to. So our horizontal is y equals 3 over 1. Just take those coefficients. Alright, y-intercept, the easiest of all. Replace x with what? 0. So we get the point 0, negative 4. And we're done.